A2, adding, subtracting rational expressions. So here's where we're going to add fractions. And if you remember from grade school, to add fractions, you need a common denominator. So that's the first thing we're going to talk about. How to find a common denominator of numbers and polynomials. Now it's actually the same rule for both, which is you take one of each. Take one of each. And then two, if they're two the same, if two similar, take the bigger. And that's how you find a LCM, or lowest common denominator. So let's see what I'm talking about. So let's do numbers. Let's go 6 and 8. Right? One way to do the LCM, the way you probably learned in grade school, is you just kind of list out all the possible multiples. So 6, 12, 18, 24, 30, blah, 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 blah. Then you do 8, 8, 16, 24, and you're like, wait, these match. That's the lowest common multiple, or lowest common denominator if you're adding fractions. So that's one way to do it, right? But that gets cumbersome when you have big numbers. The system way of doing it is just you prime factor both of them. So this is a 2 times 3. 8 is going to be 2 times 4, and 2 times 2. So 6 is 2 times 3, and 8 is 2 cubed. And what we do is what I said. We're going to take one of each. So I need a 3, and I need a 2. And now there's two of the same, so you pick the higher one. And that's going to be your lowest common multiple. 3 times 2 cubed. If we actually did that, 3 times 8, 24. So that's the process. Take one of each. Once you prime factor, I probably should put prime factor. Kind of an important deal. So once you prime factor it, then you take one of each, and if there's two of the same, take the higher one. Same rule applies if there's polynomials. If I give something like x minus 3, and let's do it with variables first. A, b squared, and then a cubed bc. Right, the exact same rule. You take one of each. So I need an a. There's two of them. I take the bigger one. I need a b. There's two of them. Take the bigger one. And then I need a c because there's a c there. You have to take one of each. And that's how you find the LCM. That's the way it works. So let's do some examples real quick. So the first one here. So again, with the numbers, I'm a prime factor it. So 12 is 2 times 6, 2 times 3. So 2 squared times 3. 15 is easy, 3 times 5. And 8 we know is 2 cubed. Right, so let's take one of each. I need 2. The biggest 2 is right here. So 2 cubed. I need a 3. It doesn't matter which one I take, they're both the same. And I need a 5. So that's my prime factor, that's my numbers. That's my LCM for the numbers. For the variables, again, we just take the same concept, take one of each. And the higher, if there's 2, take the higher one, so a squared. They all have a b. This is the biggest one. And there's 2 c's, but again, you take the bigger one. So that's the answer. I mean, I can make it a little prettier. This is 15. This is 8. 8 times 15. Let's see, 2 times 30. 30 times 4, 120. A squared, b cubed, c4. Right? That's the idea, right? Quickly do this one. Same idea. 9 is 3 squared. 7 is 7. 21 is 3 times 7. So we're going to take one of each. I need a 3. That's the biggest one. And I need a 7. Doesn't matter which one, they're both the same. So I get 9 times 7, which is 63. With the variables, I think variables are easy, right? They're already like factored for you. So you just take one of each. I need the a squared, biggest one. B cubed. And I need a c4. And that's how you prime factor it, right? So that's how you do numbers variables. And let's move on to polynomials. It's the exact same thing. What's the one rule here first before that, though? You got to factor. as always, we got a factor. So let's look at this one. Let's factor it out. Now, again, when there's only two things, this is what they have in common. They have a 3y in common. Right? They both have 3 and a y. This one, what two things multiply, you get 15, but add to get a negative 8, so they both have to be negative 3 and 5. Right, so we factor, we prime factor basically the polynomials. And then we do what we always do. Take one of each and take the higher one. There's two of the same, take the higher one. So I need a 3y, nothing else there. They both have y minus 3, I need whatever one, they're both the same power. And I need a y minus 5. That's how I prime factor it. Last one of these, before we move on. So this right here, right? Same concept, let's factor it first, that's the first step. Notice these all have an x. So x squared minus 6, x minus 16. And I can factor it some more. Two things that multiply, you get negative 16, but I have to get negative 6. 8 and 2, right? Different signs. Remember the trick I've been talking about? If it's 8 and 2, the middle one's negative, so that means it's a bigger number. 8 has to be negative. Whatever the middle one is, that's the sign of the bigger number. 8 plus 2. They're different signs. This, difference of two squares. X minus 2, x plus 2. Right? Now we're going to do the same rule we always do. Let's take one of each. So I need an x. There you go. I need an x minus 8 because it's all by itself. They both have an x plus 2, doesn't matter which one I pick. And I need an x minus 2. And that monstrosity is our LCM. So that's how I find LCM. Next up, how do we add fractions? Okay, adding and subtracting fractions. It's just like we always did, right? Always done. You need a common denominator, right? So this is like in grade school, if I give you this plus, I don't know, 3 over 4, you're going to need to find a common denominator first. In this case, common denominator is 20. We just both think, okay, 5 times 4. So I need a 20, and a 20. The way we get it, right, we multiply both top and bottom, because that's a 1, by the same number. So 12. Multiply both top and bottom by the same number. So 15. And we get 27 over 20, which is what we like. We like improper fractions. Right, we're going to do the same thing if I put variables there. If I make it, I don't know, 3 over a plus, let's put a squared, make it a little fancy, 2 over ab. It's going to be the exact same idea. You're going to go, okay, what's the lowest common denominator? Now remember we talked about this, you take one of each, so I need a squared. Right, they both have an a, but you take the bigger one, and then, oh, this has a b, so you need a b. Right, and you're like, how do I get this to have the b? Well, multiply both top and bottom by the b. How do you get this to have a squared b? Well, it's missing an a, so multiply both top and bottom by an a. And then you combine it. I can't do anything with the top besides rewrite it. That's just the way it is. And you get this, right? Same concept, just now applying it to variables and stuff. So let's do a few examples. So look at this first one here, right? Now, honestly, the way I do this is I just kind of think, what's it missing? That's how I find my LCM when it's like this. I have a 5. I need to get to a 10, right? So it's missing. Okay. So let's find LCM, sorry. So this is LCM is 10. We need one of each. 5 and 10. They both go to 10. I got a cubed and a. So I take the bigger one. I got b squared and b, take the bigger one. Right, next, what do I need to multiply to get that? So over here I have 5, I need 10, so I'm missing a 2. And I have a cubed and b squared, so this is going to be 8. This is a little more interesting. It's a 10, I already have 10, don't need to worry about that. I only have an a, they have a cubed, I'm missing 2 a's. And I have a b and they have b squared, so I'm missing an extra b. So you multiply it, what are you going to do besides 9a squared bc? Again, really you can do there, besides just rewrite it all together. But again, same concept, find the common denominator, and then just what do you multiply to get that common denominator. I actually think it's a little easier when it's polynomials, right? So step 1, let's factor this, as always we do polynomials. 2 to multiply to get negative 6 factor to get negative 1 is negative 3 and positive 2. Again, notice the bigger number is the middle sign. Over here, don't overthink it. They both have a 5 in common. So x plus 2. Now here's a shortcut I do with this stuff, especially with polynomials. I just kind of look at it and go, okay, what's missing? I have x minus 3x plus 2. This is x plus 2 and a 5. It doesn't have the 5. So I know right away I'm going to have to multiply this by 5 and 5. And if you want to distribute, you get 5x minus 5. And then my bottom's going to be that. And then you look at this one, he's like, okay, what's missing from that thing? Well, it has a 5 now. It has x plus 2. It doesn't have the x minus 3. So multiply by x minus 3. That's my little shortcut. Multiply by what you need to get. Now here, two choices. You can leave the minus sign there and then distribute the 4. I see a lot of people actually mess that up. So what I do is I like to combine these two. Let's distribute the negative 4, so it becomes a negative 4x. Negative 4 times 3, very important, don't forget that one, plus 12. All over this. And then, we got like terms like 5 and the 4, which is 1x. Negative 5 and 12 is 7. And I get all this over our common denominator. Again, we're going to do none of this, but that's the general idea. I like to factor, right? And then I just kind of think, okay, what's missing? I need a 5, so multiply top and bottom by 5. Over here, what's missing? I need the x minus 3. Top and bottom by x minus 3. Then just add it. I can actually do the same thing here. But when it's numbers, I think it's a little easier to just find LCM. When it's polynomials, it's easier to figure out what's missing. With numbers and stuff, I think LCM is probably the best way to go. So we're going to do that here. Right, let's find the LCM or LCD. I got 3 and 5, so the only thing they both go into is 15. So again, with numbers, I think it's a little easier to do this. And then you go to your variables. I have an x, and an x. You take the biggest one. And then you need a y because they have a y right there. So that's my common denominator, if I could write it. And then it's about how do you get there, right? In this case, you're missing a 5, so 5 and 5. You also only have one x, you need 3 x's, so you're missing x squared. And you don't have a y, so you need the y also. So you multiply all that by 4, and you get 20x squared y. The middle one, all you have is an x cubed, so you're missing like the 15 and the y. So that's what you're going to multiply by, 15 and y. 8 times 15, I feel like I did this earlier, 120. Yeah. And then over here, it's kind of hard to see, but I have 5. I'm missing, I need a 3, because I only have a 5. That's only an x, I need x squared. But I do have the y. So we get 6x squared. And that's pretty much it. Can't do anything else with that. You can make it all under one fraction. That's all you could do with that. Now, 31, same idea. It's just only thing you notice the difference is that this is an ugly factoring one. But it's fine. We don't mind doing this. You just multiply these together because there's a number in front. You get negative 12x squared. Figure out two things that multiply, get 12, add to get 11. Easy enough. 12x and negative 1x. So, then remember we plug this in for the middle right there. So 2x squared plus 12x minus 1x minus 6. These both have a 2x in common. These have, remember, always bring down the middle sign. They have nothing in common, so put a 1 on the outside. Negative 6 divided by negative 1 is a positive 6. That's how these match. X plus 6, 2x minus 1. So there we go. This one, that's a much easier factors. This two things multiply, get 18, but I have to get 3. Positive 6 and minus 3. Again, notice the middle sign's a bigger number. So it's all factored, right? And again, with polynomials, I think it's a lot easier just to go, what's missing? So if we look at this side, I have x plus 6, 2x minus 1. Only thing I'm missing from this side is x minus 3. So let's multiply both top and bottom by x minus 3. I'm going to distribute right away. I'm going to get 6x minus 18 all over the bottom. I'm going to be lazy and just do this because I'm lazy. On this side, right, what's missing? I have x plus 6, x minus 3. I don't have a 2x minus 1, so let's multiply by 2x minus 1. Again, there's a negative there, so just to make it easier, I'm going to distribute the negative 8. So I'm going to get plus negative 16 plus 8. And I'm lazy, so I'll just do this. Out of like terms, 6x minus 6 is negative 10x. Negative 18 plus 8 is negative 10x, 10. All over x plus 6, x minus 3, and 2x minus 1. There you go, right? Common denominator. So you always have the factor first, find the common denominator. For me, I just kind of go what's missing, multiply everything by what's missing, and then you're kind of good. With numbers, when it's all monomials, it's a lot easier to me just to find the LCD. Just separate it. Remember, with numbers, find you take one of each, and then if there's two of them, take the bigger one. Okay, almost done. Let's do a couple more. So, how do we simplify complex fractions? Well, one way to do it is just kind of do a fancy way. Like, do this first. This is one way. I'm going to show you two ways of doing this. Add those two up. So, we should be a little better at this now. What's this missing? Let's rewrite it right here so we can see it. So, one way to do this is just do the old-fashioned way. Just take it one step at a time. Figure out the top first. What's the common denominator? Well, what's this missing? X minus 6. And what's that missing? X plus 5. Distribute, you're going to get 4x minus 24 plus distribute 9x plus 45 all over x plus 5, x minus 6. You never want to distribute the bottom. Let's just set it up here also. Don't go through the trouble of distributing the bottom. It doesn't matter. We like it factored. We want stuff to be able to cancel out. So I always leave my answer like that because it's just that's the way we like it. So I get this, and then I could simplify that a little bit. I'm gonna get 13x. Let's say 40, so 21 plus 21 all over x plus 5, x minus 6. Right. So I just simplify the top. That's now this. Now simplify the bottom. Same concept, right? If I was doing the bottom. And then we rewrite it so we can see it first. So again, this is one way to do it. You just go, okay, what's missing? Minus 6, x minus 6. It should be a minus. Distribute, you get 5x plus 25 against minus 6. So negative 8x plus 48 to the minus 6. All over the bottom. Add like terms, you're going to get negative 3x, 25 plus 48. So 50 plus 25 is 75 minus 30, so 73. Plus 73 all over x minus 6, x plus 5. Right, so we get that. Now it's a complex fraction. We dealt with those before. This is just a divide sign. So you just rewrite it. You get 13x plus 2 over x plus 5, x minus 6. Divided by, so I'm just going to skip a step here, right? You're dividing by this, so we're going to flip it and multiply. That's what dividing does. You flip it and multiply. So it's going to be, you're going to multiply by the reciprocal. That's for dividing. And look what happens. These cancel out. And you get 13x plus 2 all over negative 3x plus 73. Which is the answer. Right, so that's one way to do it. One way to do it is the old-fashioned way. Just take it one step at a time. Simplify the top, do what we've been doing. Simplify the bottom, do what we've been doing. You get this complex fraction, and once you do that, you just rewrite it, right? Divide means multiply by reciprocal, and then sub-cancels. That's one way to do it. Other way to do it is by multiplying everything by the LCD. So this is it's a little more of a pro step, but what we do is we find the LCD. Now remember the way we do this. You take one of each, and if they have two the same, pick the bigger one. In this case, it's all LCD is x plus 5, x minus 6. So what we're going to do is multiply both top, it's a fraction, so we'll multiply top and bottom by 1 by the LCD. So this is a faster way of doing it. Right, it's a fraction that's 1, so you can multiply a fraction by any one all you want. And we're going to distribute this. Now remember, we're doing it to both of them. This top one here, the x plus 5s would cancel. And you just get 4 times x minus 6. The one right here, the x minus 6s would cancel. And you get 9 times x plus 5. On the bottom, right, same idea, we're going to multiply this by both of these. And you multiply these by that, the x minus 6s would cancel. You just get 5 times x plus 5. When you multiply this by both of these by this, the x plus 5s cancel. You just get x minus 6 times negative 8. And then all you have to do is simplify that. Distribute, 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 distribute. And you get 4x minus 24 plus 9x plus 45 all over 5x plus 25 minus 8x plus 42, which gets you 13x plus 21 over negative 3x plus 73. Is what I said last time? Yep, 73. Right? So same answer either way. Doesn't matter how you do it. Exact same answer. It's been 21. So last one. 2 drugs are administered to a patient. The concentrations in the bloodstream of each are given by this. Ft equals that, Gt equals that, where T is in time and hours after drugs are administered. So adding 2 functions together to determine the function for the total concentration of... So they want me to add the 2 functions together, so, right? How do you do it? Just add them up. That one plus that one. I'm not going to do the work because of time, but right, just the same concept. Common denominator, right? We're not scared of application problems. Just wants you to add the 2 drugs. And you can get some number. And look what B says. What's the concentration of drugs after 8 hours? You know what that means? Plug in 8 for T into the thing you got. Get your answer and you're done. Right? So again, don't be scared of application problems. It's just words. That's all it is. Hey, they give you 2 functions. They want you to add them together. All we've been doing today, right? Factor, common denominator, add them. And then what's the concentration after 8 hours? Just plug in your 8. That's it. We're done.